Welcome back to Ox Tools. I'm Tom. So this is part 3 of the Squareness Comparator build, and what we're working on in this particular video is these side plates here, and this actually I'm calling this a snug, and the idea is that it snugs this rod that's going to hold the indicator out here while this thing travels up and down. Okay. So there'll be a little dovetail mount at the end of this, and that's yet another video. So in this video, we're going to work on these guys here and kind of prep those and work on this. We have some excitement. Mr. Bozo visits the shop, so there's some action-packed sequences for your viewing pleasure buried in this video. Let's see, what else? I think that's about it. And then the next video we're going to do, I got some ideas for a pretty fancy knob that goes on here. So that'll be the next video. That'll be, what, part 4. Answering a couple of questions. Some people asked why 4 feet instead of having just a continuous rim around the base. Now this isn't the base. I've got it's been sent to the heat treater, so I can't show it to you right now. But the thought behind that is that 4 feet are much easier to correct for perpendicularity, because what we're trying to do is make this pin perfectly square to the surface plate, right? So if I lap that foot, I go that way. If I lap that foot, I go that way. If I lap that foot, I go this way, right? So that's kind of the general idea there. And if I have a continuous rim, that's a lot of surface area to lap. To correct for any kind of out of perpendicularity. So anyway, that's kind of the reason behind that, is to have, you know, small local feet. They're a lot easier to lap. And then somebody asked about this little device here that I was using, and this is just a let's turn it on here and you guys can see what's going on. It's just a 1-inch travel electronic indicator, and I made a little base for it, which I lapped the bottom of. And the idea is that, you know, you can measure little steps like that, and just read off of the indicator what that distance is. Now you set it. Well, I don't have anything to set it on here. No, that won't work. Anyway, you set it on a flat surface like that, and you kind of zero it out. I can't read it right now, and I might be sitting on something there. And then that just projects out. So it's kind of nice on the surface grinder. You know, if you're doing a step, you can come over and kind of interrogate that step and just get a quick reading. And then this doesn't want to stick to the magnet or the energized surface grinder magnet as aggressively. So anyway, somebody asked about that, and this is homemade. This is actually kind of a fun little project that that you can do for yourself if you have. Honestly, it doesn't even have to be an electronic one. I just happen to use an electronic one just because it's kind of nice. And I turn it on and it remembers where it is too, so which is pretty cool. Okay, anyway, that's the story on that. So let's get started. Let's work on these side plates and in the snug here, and let's see what happens. And if on the CAD, if you draw an itty-bitty little circle at the center of all these, it's actually an excellent center punch lineup dot. We're going to use the Milwaukee Portaband on the Swag Off-Road stand. So I bought one of these stands from Swag Off-Road, and well, I'll show the logo, or I'll put something in the description. And Outside Screwball, he made one, and I figured, oh, I'll try one of these out, and I actually kind of like it. One of the things that's the benefits of it is I can keep kind of a fine-tooth blade on this one and then have a fairly coarse blade on the big Dual, and I don't have to switch blades. And this is great for little cut-off jobs like this on thinner materials. So kind of works pretty good. So I just leave it set up over here, and then the only thing is the switch is a little weird. You gotta fuss around with it. Sometimes it's just easier to use a spotter on something like this, you know, where you have kind of an odd shape. So see, I'm just feeling the center punch mark there. I'll lock the quill. Lock the quill. There's a fine line there, guys. Okay, like that. And I'll just slap a couple of clamps on, like so. All right. You know, you'd have to figure out some kind of tricky holding device or whatever, and they can just pop through, boink, like that. And I'll put my pointer back in. It's just a couple of holes, so. Let's just go over there because it'll be easier. Like that. Sure, I don't even have to get right in it, because if I have the piece loose like this, that isn't a great center punch mark there, Mr. Wizard. Maybe I need to center punch. Oh, there it goes. You know what? I'm going to recenter punch that. I don't like that one, so let's just give it a little whap. I didn't like that center punch mark. Okay, so hold it down and clamp it down, right? It looked a lot harder than it was. Screwed that up. So you guys have seen me do this before. I use the simplest measuring tool at the particular time and place, right? So make less mistakes that way. Serious now. All right, so we're pretty close. I'm going to take an accurate measurement now and see what we got. I'm going for 1 inch, and what I want is a flat bottom to that step is what I want in this case. When you have little steps like this that aren't very deep, they're kind of hard to get a measurement, especially with calipers and telescoping gauges. Okay, so we got I don't know, 0.003 to go here. You know, but these are great because they have these little short, and these are carbide pins here on this one. This is a Mitutoyo inside mic. And this one's cool because it goes from 0.2 to 1.2, and it's nice because you can measure really shallow steps with this, and they make larger models too that go up to approximately 3 inches, but these are a good way to measure little steps like this. What did I say? 3,000. Okay. All right, let's, and this reads half, so that's basically 1.5 on that. Get back on center. Now, usually when you're boring like this, you know, if Mr. Bozo wasn't around, he would have left a little more space in here so Mr. Micrometer would fit in, but you know, sometimes you forget. And, but it's not the end of the world to move off center and come back to it. And this theoretically is a finish cut, so what I'm going to do is I'm going to dwell at the bottom a little bit, let it polish that bottom step a little bit, and I'm going to come up nice and slow like that. All right, let's see what we got. All right, there's the finished part. Well, the finished side. This is the snug. The indicator will mount on the end of a rod. This rod here. This is a hardened and ground rod. So I'm making the snug that will attach this arm to the sliding part. So anyway, let's put this side on because it's kind of done, and then we can work on the other side. The other side, oops, just gets a straight hole through it, just a nice clean hole. There it is. Fasteners there. Just gets a nice clean hole through it. Then we get to make a really cool knob. I got an idea for a pretty spiffoid knob. So what's going on here? Oh, there it goes. I just had it bozoed there. All right. So we'll put this hole in. I probably won't show that because that's just a straight 1/2-inch hole. But we have some lathe work coming up here. A bronze bushing sleeve, and then the part that actually does the snugging on this rod. So let's go over to the lathe and let's hit the lathe. All right, there's our little snug. So that hardened rod I showed you passes through that hole, a 5/8 hole. This will be threaded. I didn't show it. It's just a little thread relief there. And then this retains it in the ears on the comparator and allows us to compress it. And there'll be a bushing that goes over this that you guys will see in a little bit. I just wanted to show you this little chicken sketch I did just to make it easier at the lathe. They're all dimensioned off of this end, so I can just kind of work in this direction, and then part it off and then go over to the mill and do that. So let's get started on that little guy. All right, this is what we're using for that snug. And this is a 17.4 H900. So this is actually a really neat material. You guys should look it up and understand its qualities. It's what's called a precipitation hardening stainless steel. It's kind of neat. So it uses a kind of a long, slow heat treat and to bring it up to its maximum hardness of, I don't know, 40, 45 Rockwell, something like that, 48 maybe on a good day on a small piece maybe. But what's neat about this is you can machine it in the hardened state, and this is as hard as you can get it. This is this kind of specifies the heat treat, so it's a 900-degree Fahrenheit soak for X number of hours. I don't know what it is, but a machine's really good in the hardened state, and it's very corrosion resistant, similar to 304. It's slightly magnetic, so you can't use it for everything if you need non-magnetic. But it's extremely strong too. I think over 200,000 psi yield strength. So pretty neat stuff. And you can weld it. So you can weld this to other stainless steels and to itself and things like that. So it's got some kind of neat qualities. But that's what we're going to make our snug out of here. And it'll be nice and durable and corrosion resistant and the whole 9 yards. So just want to make sure I got enough sticking out here. Yeah, it looks pretty good. Something like that. So, all right, let's get that indicated, and let's do some make some chippies, huh? What do you say? All right, a little bit to go. So we're just going to put a little thread relief in this. Hopefully it doesn't squeal too much. Not too bad. So this is going to take the radius of the insert radius out of there. Is what this is going to do. And we're just going to cut in until we get a full profile. Uh-oh. Okay, I thought I got, yeah, it's got the faintest a bit of chatter in it there, but I think that's fine. We'll break that corner just a whisker. That's just so that we sit against that shoulder, you know, with nothing to bind it. So, okay. Looks right to me. Okay. I think we're time for a check. I don't know if I've showed this before, but you know, when I'm doing simple threading like this, where I just want it to fit, you know, I just have a collection of all the sizes that I've messed around with, and I just keep, these are jam nuts, and I just keep them on a wire. These are fine threads, and then I have one like this for coarse threads. So let's find the appropriate little dude. On a cooler clip or whatever, but I think this is the one. Let's see here, let's double check. Yeah, looks like the guy. All right, that's pretty close. All right, let's do a little more there. What's a crudski in there? So some people may be freaking out. This is a stainless nut on a stainless shaft. But remember that, I'll point out that this is 3/16 stainless, the nut. Okay, and it seems to fit fine now. That's how I want. See, it's marked. And this is 17.4, so we have a real high differential hardness between these two materials. So they're not gonna do the bad stuff that stainless nuts do on stainless fasteners. All right, okay, I think we're happy with that. Now a tapped hole will fit a little bit different than that, but I'm not too worried about it. So this is for the knob here. So let me take care of some icky little burrs there, and then we'll part this off. Hear that noise? It means you're getting close. Look at that finish. This stuff, you get a good finish on it when it doesn't squeal at you, so. Stay. All right. Theoretically, this should go through here. Crud out of there. All right, that's the idea. It's got a teeny little, I'll slap that off of there. It's got a little tiny little pip. I can just barely feel it. So, and then Mr. Knob goes on this side here, and you can see there's a little gap there that's intentional. And the idea, there's a bushing that goes around this, so the rod will pass through. This rod will pass through, and the hole will be slightly offset in this piece here, and it'll pull up and compress and lock the bushing, and then lock the rod at the same time. So it's, you know, it's kind of a standard snug deal. I got some fancy plans for the knob, which should be kind of fun. But meanwhile, let's we gotta, as part of this design here, we gotta pop a hole through there that fits Mr. Rugg. So let's go over to the mill. All right, so now we're gonna set up. We're gonna put a hole through the side of this, a round hole, unlike that one. But this is, you know, fairly tough material here, and I want the hole, a couple of qualities of the hole. I want it accurately sized so it fits the rod well, and I also want it centered real well in this piece here. So, you know, you can put it this way, but I think what we're going to do in this situation is we're going to put it this way, okay? And it allows me to access this real nicely, get centered up on it real well. We need to support it, in this case particularly well, because we'll be pushing on it with a little bit of force. So what I'm going to do is, let's see, parallels here. And because what I want to do is I want to put a little baby V block under here, like so, and support that, like so, okay, and I'm just going to lightly clamp it. Okay, so that's not bad, but it's not great either. So here's what we want to do is, let's see, can you see that under there? Yeah, this, I want to put something under here to support that. And this is, you know, and I've showed these lots and lots of times, and so has Adam, but if you don't have a set of these, you don't know what you're missing until you have a set of these. They're just super handy for this kind of stuff here, right? So here's what we're going to do. We're going to lower it down. We're going to stick it under there, and we're just going to slide it until it catches that little rim. And I don't care what the diameter is. I don't give a hoot, right? So now I'm bucking up against that nice and tight. What we're going to do is we'll indicate over the top of this to make sure we're not tipped. And so now we're supported on this side, we're supported on this side, so we can push with impunity here, and I don't have to have this clamped to the moon to do that. So let's indicate that. Let's see what we got there, and see how it looks, and then we will go from there. Okay. What let's see, how well can you, you guys can't, how about if I turn this around? What do you think of that? Maybe that would be nicer, Mr. Wizard, huh? What do you think? Okay, sure, whatever. Alright, so what I'm going to do is, let's bring this down until we make contact there. And then I'm just going to find the high spot there, which is right there. Not going to stress out too much about being on 0. And then we'll go over to this side, and then we'll give it a little sweep. Okay, so what is that? That's low. So we're just a shade low on that side, half a thou. Let's I'll show you how to correct that. Need a little dinker here, because what I'm going to do is I'm going to hold the end of this, and then I'm just going to tap this. Make sure that vise isn't too tight. Alright, so, okay, and it's creeping up. Okay, I'll pin that down. See if we're still on the high. Okay, 0. And now we're high on that end. So let's see if we can just push that down. No? Okay, it doesn't want to cooperate. All right, now we're a thou. One way we can accurately pick up the center is just to use the split function of the DRO. So what we would do there, come down, come over, pick up one side, carefully, okay, 0 the DRO, come over to the other side, do the same thing, that, okay, and then use the split function, center line, and it takes us back to the center that way. So just out of curiosity, I'm going to use the edge finder method, okay, so what I'm going to do is I'm going to set that as my my absolute position, okay, which I just did. And then I'm going to do it the other way. I'll show you the other way. Let me get that tool, and then we'll try it again. All right, the other way is a little more old school, and what we do is we use an indicator, and what we're going to do is we're going to use the the front edge here, okay, and we're going to sweep that and find a high spot. Oh. Come down, and I'm moving the x-axis until I zero out. So I got two high spots I'm trying to find. One is the halfway point of the rod, and I find that by sweeping this, or excuse me, vertically. So I find the high point of the rod this way. All right, somewhere in there, and then I find the max reading that way. So I'm going to bring that back to 0, like so. And I'm going to fish it again and sweep it again. Okay, so the camera's right in the way, but you guys got to tell me if I'm pretty close there. Okay, so that's pretty good. Now, without moving the indicator, what I'm going to do is I'm going to beep it and 0, and I'm going to come over on the other side this way, and then I'm going to do the same thing on this side. You won't be able to see the indicator, so you will have to trust me. I'm going to 0. I'm zeroed on incremental, and now what I'll do is I'll shift to absolute. So DRO says 0.2, the difference between those two methods. Now the edge finder is much quicker, as you can see, and pretty accurate. So that's why they're so damn popular. So this is kind of the way that you were taught before you had good edge finders, or they were commonly available. So anyway. Damn it, Mr. Wizard. Well, how do you like that? Now, here's this, you'll like this. So that was kind of exciting, right? But this is how tough this steel is. Is the part is unharmed, which I'm kind of surprised. Now I'll tell you what happened here is because we have an uneven breakout, it caught in the it caught in an edge that was left that was still thick. But you know, sometimes Mr. Bozo gets lucky, right? And look at that. I mean, frankly, I'm shocked that the part isn't chowdered, but as you can see, well, you know what? Okay, so let's think about this for a sec. So, you know, I'm squeezing on it like this, right? Okay, I'm squeezing on it like that. Now I've relieved a bunch of material here too, so it's possible that we lost some vise tension too as part of the problem, but. You know, the feed pressure on the handle here was pretty minimal. Honestly, I'm kind of surprised. So I must have lost a little clamping pressure, and you know what? I kind of got lucky, is what it looks like. So let me get it back in there. It's still not the size yet. That's not the size, and I wanted to bore it too, so that the hole's nice and straight. So what we'll do is we'll set that up again and get it straight with the world. And then we'll go back in there with a boring tool, and hopefully Mr. Bozo goes and visits South Florida or something like that for a week.